For a year and a half now, VZU and Fly for Future have been working together on a project which aims to develop an autonomous platform. This focuses on navigation and the autonomous detection of defects in space.
A system that is capable of fully automatic operation in interiors, in complex industrial halls, and between structures and beams. We are striving to ensure that such a system is capable of safe and efficient navigation, as well as visual or other inspection, that's also automated based on onboard data.
We intend to operate the Temelin power plant for more than 60 years. In practice, this means that we have to upgrade not only our own equipment, which basically produces electricity, but we also have to upgrade the methods which we apply to verify the condition of such equipment.
We launched drone inspections a few years ago, knowing that we'd have to enter development and that we'd have to try to keep pushing the boundaries further. We knew that to do so, the only ones we could unite with are Fly for Future.
We come from the Czech Technical University in Prague, where we're dedicated to the most advanced research in the field of autonomous robotics.
We provide artificial intelligence that can currently register and locate various indications. In particular, our portfolio currently includes corrosion and defects in reinforced concrete, and we'll have a package for fluid leaks.
In contrast to a human operator, our autonomous system is able to do the same inspection work any day of the year.
It's able to change its route according to what the environment looks like at that moment, and actually reach the place of interest.
It's even able to automatically analyze whether any given defect is getting bigger.
A drone can do things that would take workers days or weeks to do in just a few hours. The result is that we can carry out the inspections more efficiently and obtain much more detailed results in a way that is much safer for the workers.
We tried it on tower number 4, starting by scanning the tower shell from the outside. A map was created, and then we evaluated the individual defects. We passed to the interior as well. The next step is actually inspecting both pressure and non-pressure closed tanks and some larger pipelines. When we need to do some visual inspection of the shell, we often have to put up scaffolding. The scaffolding is expensive. Most of all, a drone can fly around and inspect 100%, which is impossible from scaffolding. So the drone is ideal for this.
I can see the potential wherever there's something that requires maintenance, something that's meant to serve people in some way and shouldn't lose its functionality. These applications are the areas where these platforms can gain ground. Nowadays, a human is needed to get into those places. A drone can actually get in, but it still needs a human operator. What will make our solution unique is that it will basically find the route and seek out the solution itself.